Hey, good morning. Okay. Um, so good morning, everybody. I hope you enjoy the music to calm your soul, get you gentle start to the morning. I realize that this is very early in the morning. Wasn't my choice. Wasn't your choice. It's all that was left. But where's that coming from? Hello? How? Only 2 minutes. I love technology, especially when it does random and weird things. Welcome to this class. Good morning. I'm glad you're here. It's 8 a.m. What is the first day of class for me? And we've got almost everybody here. We have 99% of the people who signed up are here. Do you still hear music? Okay. I'm going to go stop that. Let's go back to this. There we go. So we've got almost everybody here. And this is, I think, the most interesting class in the university. And the reason is not just because I like it, but because this is the class that is changing the most day by day. You go take physics, it's the same physics they taught Aristotle. It's the same physics Einstein knew. You come to this class, what you learn today may not be true in 4 weeks, right? So we're right at the bleeding edge of technology and what people are doing with AI. So this is a really interesting time to be in this class. It's a little bit like if you were taking physics lecture and listening to Einstein lecture, right? Hello, we're here. We're watching the world of technology and AI change day by day. So this is the course we're going to do over the next few weeks. And what I want to do is start with a little bit of mechanics, just sort of get things going. This is to take a picture, get out your phone. You want this, because this is the master syllabus for the class. And when you, by the way, when you come to the class, I have a lot of QR codes like this. So bring your phone. I know some of you don't have phones, just imagining. But we'll be, I'm still getting a delay from somewhere.
Shall I email me so that you can?
Well, I can't figure out where it's coming from. Yeah.
Let me quickly.
Well, it's not a huge problem, but we'll do it during the break. So anyway, that's the course syllabus, and now I'm going to show you the course syllabus. So it looks like this. I will tell you, it looks terrible on your phone. Look at it on a laptop. Anyway, it looks like this. Lots of academic information at the top. There's information about the staff, the syllabus, including the outline of the course, which is this document right here. This is not a precise outline of the course. The syllabus is the real outline. But this is sort of the topic we will cover during the course. Okay, so it also has it sort of refactored in different ways. So you can sort of get an overview of what we're going to cover. All right. So here, as you can see, today is Tuesday the 18th. We're going to do intro, course mechanics, all that jazz. And we're going to hand out assignment 1. Overall, the assignments are front loaded. So you'll get an assignment this week, and you'll get another assignment in like 3 weeks, another assignment in like 5 weeks. And then you have a kind of a gap, and then we'll have the final presentations backloaded. Okay, so in the middle, when you're on vacation, there are no assignments. Just saying. I'm trying to make life easy for you. So when you look at the syllabus, what you'll see here is, for example, this is the link to the slides, which are may or may not be able to see at the moment. That's the outline of the class. I will then link in the video. So after this class is done today, I will take the video and put it in there. So if you need to watch it later or go over notes or something, you can do it that way. Each class also has a set of readings. The readings are for you. I usually put little sort of comments on them about why you might want to read that reading. So, for example, this paper here, the general background of human AI guidelines from a couple years ago. It doesn't matter that they're a couple years old; they're still true. So it's worth reading. So what I recommend is before you come to class or later this afternoon, click on the links and just check them out. Right. So, for example, this one, just look at the first 2 pages. That's all you need to do. For other ones that we have later on, this one is a pretty easy read, the Google Handbook on Mental Models. So read the readings before you come to class. You don't have to read them in detail, but make sure you're aware of what's in that document. Okay. We go down. We've got fairness, AI failure, all these things. Very cool. Assignment number 3 is due March 19th. We go on, and then we'll hand out the final assignment on the 15th of April. Then we will spend the next 4 weeks putting that together. So it's going to be a team effort. So think now, who would you like to work with? Okay. Who would you like to work with? Do teams of 2, 3, or 4. And you'll do a presentation at the end. Go on and on and on. And then the 21st and 27th of May, we'll have presentations. So each of your teams will stand up here and give a 3 to 5 minute presentation, depending on how long we get for each one. Okay? So that's the order of the class. Okay, now you got that. Quick intro. I'm Dan Russell. I'm your lecturer for this course. I've been doing AI since the 80s. I know that's the pre-dawn, but it was a really interesting time. And so I've seen AI come and AI go and AI come and AI go. So I've lived through multiple iterations of what it means to do AI. And when I got my PhD, I was a classical AI guy, a real nerd, the way you might think of ML people now. I love ML people, but you're nerds, right? And so I was deeply into the mechanics and the software and the engineering, and I built all kinds of systems. Great. And then I had this really interesting experience where I realized that the human aspects of AI were the gating factor. They were the most important. And so I switched. I worked at Xerox PARC back in the days when we were inventing things like Ethernet and Smalltalk and stuff like that. I worked at Apple for a while. I worked for Steve Jobs. I have Steve Jobs stories, which I will tell you not on the recording. I was at a startup because when you're Silicon Valley, which is where I'm from, you have to go to the startup. Just the requirement, right? You have to go. Went to IBM for a few years and I built an HCI group there. I spent the last 17 years, however, at Google, sort of being the lead user experience researcher for Search, which is their big AI product, right? So I know a lot about Search, up to the point where I wrote a book about it. That's the joy of Search there. It's still available in paperback, I think. Did pretty well, pretty happy about it. And I've taught HCI courses for over 20 years. I've taught AI for, I don't know, at least 15 years. And this is the 6th iteration of this class. So it's well worn. However, as an instructor, it's a difficult class to teach because, like I said, the 6th iteration has almost less than 10% content shared with iteration number 1. So that means I work as hard as you do. It's a great field to be in, really fun. Here are links if you want to, oops, that's wrong. You get by email off the first one. I taught this class last semester at Stanford. In fact, I'll explain later. This course is co-engineered with Peter Norvig. Anybody know Peter Norvig? Anybody recognize that name? Yeah, he's written books you probably have studied. So Peter and I worked at Google together for a long time. And if he were here today, he would say that he got his PhD in AI about the same time I did at Berkeley. I was at the University of Rochester. And he did a bunch of stuff at USC and Berkeley and Stanford. And so he was at NASA, at Sun, multiple startups, and he's been at Google longer than I have. So Peter joined Google pre-IPO. I was smart enough to get hired by Google, but post-IPO by a month. Like, timing is everything. Everything. Anyway, so Peter's done a bunch of really great books as well, and he and I work closely together to put this class together. I hope we'll be able to get him to give a lecture in the course later on. He's in the syllabus right now, but he'll probably be speaking about programming and AI. Anybody interested in that? We all are, right? So that's Peter. And we have our third co-conspirator is Ibrahim. Ibrahim, stand up and say who you are.
So we are PhD candidate here in Zurich. Been to active data analysis lab was the which then 2 years ago.
Yeah, that's right.
I'm back.
Oh, actually, only 14 months ago. You realize that? It was in December 2023. It was the last class we taught together. Yeah.
Okay, you can do the math.
Yeah. It's technically 2 years, but those are integer years.
Yeah.
So it's 1.3 years.
Before starting my PhD, I worked at Lego, a brick company, in a hospital, and I was UX UI designer and the app developer in Medicaid. Yes.
Great. Thank you. Thank you. So Ibrahim is the guy to contact if you don't want to talk to me. So he's got his email there and his LinkedIn, and wonderful. We worked together in the last class, so it'll be great. Here's what I expect the course to be. This field, HAI or HCI AI, is not a super coherent field. It's not like group theory in math. It's not like quantum mechanics. It's a whole pastiche. It's a lot of different kinds of things all put together. So we're going to be focusing almost exclusively, though, on the human side of AI, right? You want to learn ML? This is not the class. I'll talk about ML, and we'll touch on it, but we're not going to focus on it. But how people use ML, that I care about. I care a lot about how people understand these systems, what they think they can do, the ways they misunderstand them, and the way expectations get misaligned. So this is going to be a big survey. That's what that whole course list was about. You also, as I mentioned, have to be aware that things will change week to week to week. So, oh my gosh, there's another release of Grok. What does that mean? Is it better or worse? I'm going to give you a little bit of taste of that. In every lecture, I will do AI news of the week. So we'll talk about that sort of latest thing. But I'm not going to focus on, does Grok 2.0 score better on the XYZ benchmark than any other one? We'll mention that, but it's not going to be the focus. What we are going to focus on is how people think about and use AI systems. I've watched a lot of people use AI. I've watched a lot of people use complex systems in general. And AI systems are now complexity to the nth power. So how are we as humans going to deal with this? So this is really a giant collection of these things from the human perspective. We care about humans. So this is the long list of goals. You can look at it slides later. This is what I want you at the end of the class to be able to do. Talk intelligently about what basic issues are, what kinds of user experiences for AI systems currently exist. Because there's not an infinite number, there's a relatively small number. What are they? What are the trade-offs? Which one is good for what situation, which isn't? What are key issues around things like the ethics of AI, data ownership, data pipelines, all that stuff? And what do constituencies, who does AI systems, who do they serve? And where's this going to go in the next couple of years? I'm not going to make even a 5-year prediction. I'll make like a 6-month prediction. And that's about as far out as we can go. Overall, I want you to leave this class thinking, I know how to make your AI system better for people, right? Because there's a lot of software engineers who know how to make their AI systems converge. They know how to make them answer in within 100 milliseconds. We're not those people. I care about how people think about, feel about, react to, and use AI. So technical details, we meet here from now till 9:45. My office hours are right after, So, Ibra, can you hang around after class usually, or you have something else?
Most of the time, yes.
Okay, most of the time we'll. That's true. Sometimes I have to go somewhere too, but generally we'll just hang out, come chat with us, have coffee, whatever. If you want to sort of have a one-on-one longer time, email me, email Ibra. We'll figure out some time because I'm here until June, right? Okay, so what we expect of you is show up. I understand that sometimes it's hard to get out of bed at 6 a.m., get on the train, but I'd really like it to be here. There's a lot of reasons for that. One of which is that we do a lot of in-class discussion and we have a lot of in-class exercises where we will actually use little AI systems. So if you miss that, watching on a video is really, really boring. So don't be that person. So show up if you can. We have these assignments, the final presentation, and the way the class will work, we'll show up here about 8:01. I will start talking. And usually what we'll talk about is what happened in the last class. What did you think about the last class? What did we learn? We meet on Tuesdays and Wednesdays. So we have from Wednesday at noon until Tuesday at 8 a.m. to think about the class. I hope you do. I hope you get a chance to reflect on these things. I'll lecture for a little bit. We'll have a little bit of a break, 5-minute break, and we'll have a second lecture and or activities. We'll have things to do and discussion in class. And then at the very end, as you're walking out, I'll put up a QR code. The QR code links to a Google form, which has one question on it. It's not a trick question, but it's a trick. It's not a trick question. It's a question about the lecture. And if you've been paying attention, you go, oh, done, walk out. If you haven't been paying attention, you go, oops, now I got to watch the video, right? So I want to get a sense for what you're picking up and what not. Because I've taught this class before and given a lecture, and then the answer, half the answers are wrong. I think, what did I do? How did I fail you? I don't want that to happen. So this is a quality check for me. So if you fill out that QR code at the end, that'd be great. We'll always have it. That's how you know class is done. Show up the QR, right? Applause, people go crazy, and you can leave. So that's the class. What we've got are, whoops, I can see a couple things here. That's not October 3rd, whatever it says on the syllabus. But we've got 3 assignments and the 4th group project. Again, think about who you want. We do the debrief thing, and what I want you to do, my goal as an instructor is to have you learn this content, okay? One of the temptations you will have will be to use ChatGPT to write your assignments. Don't. I'm not going to check, but the reason I say don't is that if you don't engage with the material and have a little cognitive friction, you're not going to learn anything, and you're wasting your time. I'm here to teach the class, so I hope that you get, something out of it. So if you can't make it, let me know. Or if you can't do an assignment, let me know. Let me and Ibra know ahead of time so we don't mark yours as missing. So just stay in touch. So the first assignment is linked. Don't do it now. But the first assignment is basically to listen to 2 short TED Talks, basically, on AI and education. You're here, you're learning, and you're going to be in education for the rest of your life, right? We live in a time where you constantly have to learn new things. AI is going to be a big part of that. So I want you to be thinking about, what does it mean that we've got these AI agents that say they'll teach me how to build rocket engines? How is this going to affect your education? As you know, lots of code now is being written by AI systems, right? If you're planning on being a software developer, you want to know what's going to happen. If you're a graphic designer, you need to know what AI systems can do and not do, right? So I hope you take that first assignment, listen to those 2 TED Talks. They're both short, they're like 12 minutes each, and then write a reflection on what you heard and what you think about AI and education for you, because this is your future, okay? Like I said, we'll front load the work, then have a kind of work pause in the middle, and then we'll have the final presentations. All right. Any questions? Any operational questions? Life, the universe, and everything. Yes.
How long is PSA going to be?
It says in the assignment.
It's an hour.
Two pages is fine. What, I mean, I've seen people do a good job in one. Do not write long essays because Ibra and I will have to read them, right? And there's 76 of you. If each one takes 10 minutes, that's 760 minutes. Divide, you can do the math, right? That's a lot of time. And that involves not just reading, but analyzing and commenting and all that. I would prefer it if you do your, write up your assignments in Google Docs and leave it so we can edit it, please. Okay. You'll see at the end of the assignment, there's a turn it in link. So click that link, upload the, upload the link and make sure it's editable. If it's not, I will send you a little nasty note saying, please. Sorry.
Like, are the individual assignments all like analysis tasks?
No, they're all different. All different. The second or third one is to use an image generator system to create a specific kind of image. And it turns out that this is an interesting problem because it sounds trivial and it's trickier than you think. Okay, we'll talk about that when we get to it, but they're all different. Okay. Anything else? Okay. So just as a credit slide, this presentation, this class is a product of Peter and me putting this all together, but there have been lots of other people involved. So these are all folks that's mostly at Stanford and at Google and around the place. And so they're people who are well known in the field. So thank you, folks. Okay. Okay, that's the beginning. That's the end of the beginning of the first mechanics section. I want to switch into the introduction to the whole field. Okay. And as I said, every class we'll start with AI news of the week. And here's my favorite AI story from last week. An AI company, Anthropic, asks their applicants not to use AI in their job applications. The irony kills me, right? So Anthropic, which is a company that makes Claude and a bunch of other things, has asked their job applicants to please don't use ChatGPT or Claude or whatever in writing your essay or doing your whatever, right? Because what they found, it's a little bit like giving someone a take-home exam. A take-home exam in the age of the internet is stupid, right? I know you. We all look up stuff on Google. We ask ChatGPT, right? So it strikes me as very funny that this is something that they now have to say explicitly. And it's even true, I've seen this happen doing job interviews where I'll be talking with somebody and I'll say, well, how would you write a piece of R code to do the following? And then they kind of go blank for a second, and then they pop up a fully formed piece of code. I think, wait a second. There's no way I could have typed it that fast, right? So it's clear what's going on. And so the AI companies now don't want you to use their products for the purpose of job interviews. This is the future of work, right? We will come back to this topic, but I thought this was an interesting news item from the week. So here's what we're going to do today. We'll talk about a few definitions, AI and so on. So give you a little bit of history. I lived through most of the history, so I can give you a first-person perspective. And then we're going to end, and we probably won't finish it all up today, but we'll end up with the second half tomorrow. Okay, people interacting with AI systems. So what is AI? Well, to first order, it's building a piece of code, building a system that does the right thing, right? But that's what software engineering is. Oops, what's the difference? Okay, so for an AI system to do a complicated task, what we mean is that it has to deal with complexity and uncertainty that are tasks that people do with intelligence. This notion of what people do with intelligence will keep coming back. I'm not going to define intelligence because that's a fool's errand. You can spend days arguing about what intelligence is. We will talk about it through the course, but trying to come up with a crisp definition that makes everybody happy is almost impossible. Having said that, we will talk about it a lot. Contrast that with software engineering, which is basically doing the same thing, but with complexity. Okay. So here's some contrasting applications. So a traditional software engineering task might be building a banking program. Has anybody done banking programs? Anybody? Okay. Yeah, this is Zurich. Why, of course, you guys are here. FinTech folk are here. And it's complicated, right? Legacy backend systems, complicated network of all kinds of stuff. And then you've got things like chess playing programs or expert systems, which are what we would call old school AI. So we'll talk about what that is in particular. And then you have sort of more modern applications of AI, like self-driving cars or language translation things. Okay. So here's the way I would categorize them. When you contrast AI systems with traditional software engineering, so if we've got a self-driving car, the problem is it doesn't have all information all the time, and the information goes in and out very, very rapidly. So as the self-driving car goes down the street, it sees a pedestrian. After it passes the pedestrian, it forgets the pedestrian. You don't want to keep track of absolutely everything you've ever seen, ever identified. So you have this partial observability thing. Then we have multi-agent kinds of systems, which are both true in banking and in AI systems, and in, for example, chess playing programs. The classical AI systems had to deal with multiple agents. Now, agent is a reserved term. We will come back to what agents mean. People have heard about agent or agentic programming AI systems? Yeah. Anybody else has heard about that? A couple. You're going to hear a lot more about it over the next month or two. It's a ramping reserved term. But agents means a lot of different things. AI agents we'll talk about, I think, in 4 weeks or so. But we'll come back to that. Mostly AI systems are non-deterministic, especially now. Right? You ask a question of ChatGPT, you ask the same question tomorrow, you may or may not get the same answer. Right? So we have all of these interesting complexity problems. We live in the AI systems live in dynamic worlds. They have multiple attributes on their what they're trying to accomplish. They work in unknown environments, which is a huge problem for self-driving cars. So at Google, in the self-driving car project, there was the old lady with the umbrella chasing a goose problem. And this was a case where the self-driving car is going down the street, in fact, right in front of my building, where we have a big pond, and there are geese in front of it. And this lady is chasing a goose with an umbrella. Yes. And the classifier had no idea what to do. I don't know what to do, so it just stopped. That's not okay. So you've got these problems that are sort of underdetermined. That's why we say they have to work in unknown environments. And of course, the standard issues of software and computational complexity apply. Okay. So you can think about one of the aspects here of intelligence is thinking about human behaviors with things like driving or optimal behavior with things like games. So it's very easy to define an optimal behavior for games, right? You win, you lose, you score on chess or in Go or something. It's very clear what to do there. What is optimum behavior for driving? Well, I can recognize terrible driving, but it's very difficult to define optimal driving. Car arrives at destination without killing anyone. That's good, but not optimal. So it's very difficult on this left-hand side to say what optimal is, right? And so we think about how humans deal with these things. So they have actions that they take in the world, and they think about them. Then we've got in the more symbolic representational world, things like games or they're improving. We have this distinction between what humans do and what is optimal. Let me just give you an aside. You may think you're optimal. You are not optimal. You're good, but go ahead, try to prove that anything you do is optimal. It's really hard. But classical AI systems have had to have a notion of optimality, right? So we have this distinction. So let me ask you, this is an example of the kind of thing we're going to do in class. Ask your neighbor for the next 3 minutes, what's the difference between building any random software and building an AI system? I'm curious what you would say. Think of can you think of an AI application for each of these quadrants? Go. Turn to the person next to you. Say hi. My name is. Okay, everyone, that's 3 minutes. 3 minutes is pretty fast. First off, you're great. When I did the same thing at Stanford, there's a big lecture hall and everybody sits the maximum dispersion pattern. So nobody has to be near anybody else. And so you're very communicative and I appreciate that. Thank you. Did anybody come up with a great distinction between building software and building AI? Anybody? What do you got? Chat.
You need data if you want to build AI application.
Current AI app. Yeah, you do. Absolutely. Need lots of data. What do you got?
I think building software is more like modeling objects and systems, but building AI is replacing processes.
Oh, replacing processes. Interesting. Okay, very good. Yeah. How about people in the cheap seats back there? Back rowers, come on. You must have thought of something. Uh-oh. We're going to swap you guys with people in front. Anybody else? Anybody else? One more thought. Oh, how about finding an application for any of the 4 quadrants? What would be a great application that's not up on the screen? How about optimal action would be what?
AI trading.
AI?
Algorithmic trading.
Algorithmic trading, yeah, right. So agents that act on the stock market to set, buy and sell things, which incidentally has led to multiple crashes in the stock market. But we'll talk about that later. Okay? So just as a hint, part of the point of doing these conversations is that you then say and answer. Okay, okay. Now you know how it works. These things will come up again. Okay. So a little history. AI has not always been the way it is today, where you see it on the cover of every magazine. You see it, getting millions of dollars in investment capital, where people constantly show up in front of the governments of the world proclaiming that they've solved the mysteries of the universe. Hasn't been like that. So back in the 50s is when AI really started with the Dartmouth conference, 1959. That's when the first notions of AI were first being talked about. And it kind of started ramping up, gained importance and influence. People started writing. And in the 70s, early 70s, there was this amazing bubble of AI. So I went and started getting my PhD in the late 70s. And so my PhD is right there. There's no correlation between my PhD in AI and the AI winter, but it was a tough time to live through. So I ended up, going off to a big research lab which had adequate funding. It was all good. But there was a real problem because the AI systems that were promised in the 70s couldn't deliver. Or rather, they were really fragile. They would work on the examples that you gave them. For instance, there was a famous program. It's a natural language speech recognition system to play chess. So remember, chess used to be able to get a PhD by writing a chess playing program. It's not true now, so don't try it. You go to the store and you can buy a chess app, right? But at the time, people would then say, "Hey, I've got speech recco and I've got a chess player. I'm going to talk to my chess playing thing." And if you say things like pawn to king 4, fine. But if you said, "I would like an Apfelstrudel," it would move the pawn to queen 5. Right? It just would interpret whatever you said in terms of chess. So it was very fragile. You did anything outside of the box and it would fail in an interesting way. That was AI winter number 1. So we lived through the 80s and we start having same inflated expectations. The same thing happens again. Boom. But late 2000, we start working on new, neural networks and new kinds of AI start to develop. Fine. Now we get this new explosion. I'm not predicting a dip, but if it happens, you should not be surprised. Then the problem is always what the Gartner group calls the hype cycle. You heard this phrase, the hype cycle, where the hype, and you get Sam Altman saying, "Oh, it's going to do everything. We're going to have artificial general intelligence. We'll replace people. We will replace 50% of programs." People really say this. "We will replace 50% of programmers in 5 years." And then that doesn't happen, and then the value goes down, right? And then you get little things like the DeepSeek effect that happened a couple of weeks, 2 weeks ago now. So as you know, it costs a lot of money to build these AI models. I was talking to one friend in Silicon Valley whose company spent $1 billion in pre-training time. $1 billion with a B dollars on AWS to train their model. And they're not going to get it back with that one, right? And so when things like that happen, all of a sudden, blah. So DeepSeek comes out and they say, "Hey, we built a model that's competitive with OpenAI's model, but for 1/10 the cost." The world goes crazy because nobody expected that kind of thing. So you're going to see a lot of that coming and going. Don't panic. Don't panic. Right? You have to remember this. This is the way this field works. So, but what I think is different this time, data. We have these machine learning models which live and die on the amount of quality data that they have. We've got a lot more data. We've got a lot more computational power. We've got NVIDIA producing these chips, which are amazing. Algorithms are getting better and better all the time. So what DeepSeek did, we'll come back to DeepSeek if you don't know that story, but what DeepSeek did was a very clever algorithmic tweak to basically reduce the cost of training by a lot. We're also getting a lot of investment. And truthfully, one of the big things that happened was when OpenAI released ChatGPT as a chat application. Now, as a UX person, slightly offends me That's the way people got to know AI? Through a chatbot? Really? But that's the way it works. And it became very easy for lots and lots of people to uh, uh, take it on and use it. And so that was an important step. So we're seeing lots of investment, lots of uptake by governments, and we're starting to see applications working. So this is pretty amazing. So this is a data chart for the same kind of thing. The amount of data, so these are all log plots, right? Semi-log plots. But what I find so interesting is that these are papers documenting the amount of computation used by year, and then it goes super exponential, which is pretty amazing. So that's a log plot, and that goes, you know something's going on. You need to pay attention to this. So this is basically showing you different ways that we can get these things, these AI systems work. So there are multiple kinds of AI, right? So here's, to go back a little bit. So when I did my thesis in the 80s, I was building an expert system. Basically, to build plans, to build sequences of steps, what we would now think of as chain of thought or chain of reasoning, basically. And what we would do is go talk to an expert and say, "You're an expert. Let me talk to you. Tell me, how does it work?" Right? And then she would say, "Well, when you see this, I do that." And so you would tell me all the materially important things, the content of your expertise, and I would write it down in code. It was great, but it's fragile. It's very fragile. So machine learning then comes around, and they generalize from all this data we have, all these examples. There was first wave machine learning, which had a lot of examples and driven from particular examples, as opposed to being learning off of just code, language-based, text basis. And then we get deep learning that does the same thing, except in multiple steps. And where people are going and talking about today is what's called HCI, or artificial general intelligence. Now, I wrote down here, it's AI systems that solve open-ended classes of problems. And what you'll hear people say is it's things that people can do now that AI systems can't do. And when they have AGI, they'll be able to do it. That's a terrible definition, right? It's like, well, I can't tell you what it is, but you'll know it when you see it. There's a famous ruling in the US, the Roberts definition of pornography, which is, I don't know what it is, but I know it when I see it. That's what AGI is, right? So here's an example of, I think, what an AGI system might do. So this is in Google Maps, for example. You could say you have to return your rental car to the airport, and you might say to your AGI system, how do I do that? And the AGI system might say, well, it's 23 minutes to get there by bicycle. Okay. I have to, this is Peter Norvig. I have to return a rental car. Should I go by bicycle? And ChatGPT says, well, there are all these factors you should consider, right? Distance and terrain, weather conditions. Like, okay, what went wrong here? We're going to be doing a lot of things like this, where things go wrong, and that gives us an insight in how these things are working or not working. Okay. So a real HCI would say, no, you should not go by bicycle to return a rental car. That's what it should be doing, right? This is a more reasonable answer. Okay, so the way we think about these things is all these deep learning systems and machine learning, AI in general, is basically a subtype of complex systems. You're all learned people, you understand this. So now let's turn to human-centered AI. This is what the course is all about. Now you have that behind you. So we're interested in what works for people, what gives you an advantage, what's fair, and what doesn't cause harm. Because just doing things that work and are fair may still cause harm, right? So we have to break that out. We care about users, their stakeholders, and society. That three-way split is going to come up time and time again throughout the course. So it's really kind of a framework. We want AI systems to be what we say compatible with human brains, which we'll talk about next week, and human behavior, what we know about how humans work. Ultimately, we want to augment and not replace humans. Although I will say that there are people who want to just replace humans, but they're wrong. We want to augment what human capacities can do. In particular, when we talk about creativity, like I think the 10th week, we'll talk about augmentation. And ultimately, these systems have to be understandable. Black boxes are no good. We'll talk about what are called aviation surprises. It's when a plane crashes because the pilot didn't understand what the plane was doing. So an aviation surprise is a non-understandable AI, right? So there was, the famous Boeing crashes a couple of years ago where pilots were taking off and it ultimately, the avionics took over and flew it into the ground. The plane flew itself into the ground. Like, that's not supposed to happen, right? But the most common thing you hear is on the black box recordings are the pilots saying, "What's it doing? What's it doing? Why do I not understand what's happening?" So that's what I mean by understandable. Now, most of us will not be in a situation where our AI system is trying to kill us, but it's already happened, right? So this framework, users, stakeholders, and society, there's there are 3 levels of abstraction we want to think about as we develop our AI systems. So for a lot of you, you're going to go into jobs in a couple of years where you're going to be thinking and working with AI systems for all of us. Right? I want you to take this in as part of the way you analyze the development of an AI system. I want to think about the users, sure, but more than that, I need to also think about stakeholders, and that's sort of okay as well. But we also need to think about the effects on society, the effects on everybody in aggregate. It's not enough to build a system that's great for you, but destroys the planet. We do not want to have planet-destroying AI. So we want to avoid that, right? So here's a couple examples of that. The user, stakeholder, society decision. As you probably know, there are AI systems that help judges determine how much of a penalty, how much of a fine, how much of a prison sentence someone should get. And so these things work for the user who is the judge, right? Who are the stakeholders? Think to yourself for a second. Who are the stakeholders? The defendant, person who's in jail, he cares, she cares. The victims, which you might not have thought about, the families of the victims. You see what I'm doing with this? I'm trying to open up your mind so you think about more than just the user here. And what about the societal impact? What is the effect in the US? We have this huge mass incarceration problem. Perpetuation of bias in these effects. We're going to go into a case study later on in like week 3, where we talk about bias samples in exactly this case. Let's do another one, self-driving cars. I live in Silicon Valley. There are self-driving cars going up and down my street every day. When I go to San Francisco, I get in a self-driving Waymo car. I pay by phone. I get into a car that's just driven up, drives up, picks me up, says my name on the outside. I get in. The door locks. The door locks. And that does not bother me. The door locks behind me and it drives off into traffic. And I don't know if you've been to San Francisco, but it's a lot like here, except hillier, right? And so it's a city of 7 or 8 different hills, and it's like this all over the city. And there are crazy people driving, crazier than here. People here actually follow the road signs. San Francisco, optional. So who's the user? Well, the user that's obvious is the person, the driver, the person who's in the car, rather. Stakeholders are other cars, because you have to interact with them. And not all of the other cars are self-driving cars. Some of them are driven by people who are drunk or sleepy or just angry. We have to think of them as stakeholders too, right? Pedestrians, oh, right. Pedestrians, bicyclists, people who are going down the street fall into the trolley, into the tram track and fall over we have to accommodate them too, right? And society, how does developing an AI system like self-driving cars change society? Now, here's an interesting point because the self-driving car companies like Waymo or Tesla or whatever, Cruise, they will say to you, we will change your city. We'll give you self-driving cars, taxis that you can rent, you can get them to come pick you up, and we will reduce the total number of cars in your urban area by 10% or something. Is that true? How would you know? How would you model that? So this is the kind of thing we have to think about because this will change the urban landscape. It changes the way people organize their space, their lives, their time. Changes the quality of life. Here's an example. Where I live, you can take the tram from my house up to San Francisco, and it drops you in the middle of nowhere. At which point you then have to get on a bus. If you want to do anything, you have to get on a bus or take a taxi or something, right? I don't know why. Don't ask. It's just California. But Waymo has really changed that because now the train is pulling into the station, I just boop, 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 boop. I walk out and there's my car waiting for me. I feel like a very rich man because I have a personal driver waiting for me that I know will get me to the end. It's relatively cheap. It changes the quality of my life. It changes the way we think about wealth because now all of a sudden you have an urban change where you can live pretty much wherever you want, right? These all are examples of the way building an AI system can change users, stakeholders, and society. I will also comment just because I don't think I've got it in another slide, but one of the things about the Waymo cars in San Francisco is that they all have a parking lot they go to around midnight, 1 o'clock in the morning, because the traffic, the demand goes way down. So rather than just drive around aimlessly, they all go to a common parking lot and park. And they sit there, right? They get charged up and all that stuff, right? And so it was 2 months ago, there was a software update pushed to all the cars, which means that this effect of it was that if a Waymo car was backing up and another Waymo car was behind it, the second car would go beep, fine, except in this parking lot, it's right next to a bunch of apartment buildings. And at 2 o'clock in the morning, all these cars start coming in and beep, 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 beep. Drove the neighbors crazy, right? I mean, this would never happen in Zurich. But all of a sudden, you've got this cesspool of cars beeping at each other at 2 in the morning. They had to roll that one back. So the ordinary way of thinking about automation is either less automated or it's more automated. Low versus high, right? So this is the one-dimensional automation. Notice it doesn't include stakeholders, society, and that stuff, right? And so we think about high automation, full self-driving cars, low automation when you have to actually manually do everything. And in the space of self-driving cars, speaking of which, I hope we actually get a lecture, invited lecture by one of the people at Waymo. So we'll see if we can't make that happen. But one of the things he will tell you is that the automobile industry, the AI automobile industry, has defined these different levels, 5 different levels, 6 different levels. There's zero automation, but then all the way up to full self-driving. And what we're doing in the AI world is trying to move the automation up. And so, for example, high automation is number 4 here, is the vehicle is capable of performing all driving functions under certain conditions. Snow is not one of those conditions, right? So maybe that's good for Phoenix, Arizona. Maybe it's not so good for parts of Switzerland, right? And the driver, more importantly, may have to take control of the vehicle, right? So as opposed to full self-driving, where a full number 5, which is the target. Now, what Google did, and I think they did correctly, is there are cars out there that do 2 and 3 and 4. And before Google released the Waymo car, they said it has to do number 5. Has to be completely self-automated. Right. We have found in studies, one of the worst things you can do to people is to say, hey, you take control. You drive. You've got 2 seconds to take command. That's the worst possible user interface design. And the reason is, well, you'll see I've got a picture of a guy sleeping in a Tesla, driving down the freeway at 100 kilometers an hour. And he's out. If the car then says, hey, I need you to take control in 2 seconds, not going to happen. Right. So we've got this notion of Ben Schneiderman, where he talks about the two-dimensional notion of automation. We've got low versus high, and human control, where people are engaged or not engaged. And so you've got this interesting set of trade-offs here. How much automation do you want? Think about this cartoon. AI turns this email into a bullet point. So I can pretend I wrote this, right? And you have the recipient saying, oh, AI makes a single bullet point, right? So how much automation do you want? Okay. Now, I know you could write a script, a little piece of code, an agent that would go into the syllabus for this class, pull out the homework assignments, and generate the answer to the homework assignments. I don't recommend that, right? I know you could do it. I know you could do it. But I don't want you to do that any more than I want this double-ended service, because then we just have agents send the emails back and forth and I can just go take a vacation. So what we're looking for in this class is really augmentation and not replacement. So this is an old myth. This is the Greek myth of Talos. So people have been thinking about this for a long, long time. There have been multiple myths like this. This is a mechanical person, a mechanical warrior that would defend the island of Crete in the Mediterranean. And so people have been hoping for this forever. And after 2,000 years, we're almost to the point where we can build these things. We're almost to the point where we can make automated warriors. Question, do you want that? What's the effect going to be on the user, society, and stakeholders? So there's a lot of versions of this, and including there was also a very simple device. This is a kind of a mid-journey rendering of a device that was built at the time, roughly 0 BC, 0 AD, which could a chariot that was steam powered and would follow a path. It was the first programmable device built by Hero of Alexandria. And it was this little widget. It was a programmable chariot. Holy great. Couldn't do anything useful with it, but the notion that you could build such things has been around forever. So this is a perfect time for our break. So let's give you a 5-minute break plus a conversation. So if you want to walk outside for 5 minutes, that's fine. We'll start up again at 5 after 9. Okay. What's the difference between human-centered AI and just regular old AI? And if you can think of it, have an AI application in mind using that three-way choice. Hey, everybody. You've all had a few minutes with this. Does anybody have a good example of the difference between human-centered AI and ordinary vanilla AI?
So for my classmate Tamana, she thinks it's the difference in whether it's human impacting the application or we human are truly deciding the application. Because nowadays if we use kind of algorithms, deep learning, kind of things, the users they may not know how the AI functions and how can we decide the outcome of the application. But sometimes perhaps stakeholders or other experts, they can know what's happening inside the application.
Got it. Okay, very good. Very good. Do you want to go?
Yeah.
We're good.
It's going to be against what you think, but it's I feel AI, this AI is to replace humans and human-centered AI is to augment humans. If
okay.
Just AI, it's
Just augmentation.
yeah.
Right.
AI is just
No, I have no doubt that AI will replace some people. I'm trying to figure out what the best augmentation practice would be. Anybody else? How about an AI application with the user stakeholder society? Hmm? Volunteering is a great idea. Yes.
There's an application called Rosebud.
Called
Rosebud.
Rosebud. Okay.
And it's a journaling app.
Okay.
And at the end of the week, it gives you like a report on how you were feeling and insights about your wins that you may not have, figured out from your own journals. And
Great.
it gives you an insight into your own
Interesting.
mind. Yeah.
I'm going to have to try this. So Rosebud as a way of reflecting on their journaling practice. And so what's the user is obvious. Who's the stakeholder here?
With friends, families.
Oh, you would share that? Wow.
No, not with but no, I think it makes the user like more happy.
I
And
see.
that
I
really
see.
has-
Ah, very nice. Very nice. And how about society? Anything there?
Yeah, I think it's a good mental health practice. So I
I
think
see. Yeah.
as a whole,
Very good.
it can increase the happiness of like if everyone
Right.
engages in this sort of practice.
Okay.
It can,
So I'm going to repeat what you say because those guys can't hear it. So the Rosebud application has obvious user benefit. Also, stakeholders could be the family because it makes you a happier person or more insightful. And society is that the societal impact would be that it helps in mental health of a community as well because it makes people better off. That's great. That's a really nice analysis. Anybody else? Wait, you already said that. I need somebody else to talk. Yes. Thank you, back rower. Let's hear it.
We chose Elite AI. It's a New York-based startup. And they're basically an AI agent focusing on different areas, but one of the biggest areas is the healthcare industry.
Yeah.
They're basically taking over the role of receptionist and answering calls and
Yeah.
email.
Have you used it? Have you used it?
No, it's not recently.
Oh, okay.
Like in Europe. It's just in America.
Oh, I see. Yeah.
Yeah, but
It's terrible. But you're absolutely right. I mean, that's exactly the model. And I should say it will get better. It will absolutely get better. But the first, they really did too soon. But that's a really good example. So basically, having an intelligent agent sitting at the front desk as a reception. That's a great example. Okay, let's keep going. So I showed you the chart earlier, which had the different waves of interaction and the AI winter, AI summer. So here we've got kind of the same thing, except with some details, right? So back in the 80s, when I started doing AI, it was all expert systems. We would build things by hand, and we were trying to capture the knowledge in the head of the expert. Right? And Ed Feigenbaum is probably the best example of that. I know it. Actually, I know all these people, but nevertheless, Ed is still working in AI at Stanford. And then 1990s, we saw the rise of machine learning. And actually, at this same time, as people like Udaya Pearl and people were developing ML algorithms, the first ones, people working on neural nets. I was working on neural nets actually back in the late 80s and early 90s as well. Jeff Hinton, though, over here, who you probably all know about, was working on the same in that same area at the same time. And my analysis was, oh, this is silly. This is not going to work. Shows you how much I know. But Jeff stuck with it. In the 80s, we didn't have enough computation. We didn't have enough data to actually make them work. And Jeff was super optimistic. Yeah, well, someday we'll have a computer that has a petabyte of memory. Imagine that, right? Now, of course, my laptop has a petabyte of memory, but he persisted with that. 2000s was the period of big data. We started getting things like self-driving cars. So the Stanley system was the first time that large data had been collected from a sensor platform like Stanley, which won the DARPA self-driving car competition back then. In 2010, Fei Li, who is now the head of the HCI program at Stanford, was at Google, and before that, she had collected a bunch of so she built ImageNet, which provided great image training data for people who want to do image reco. And then you know the rest of this. So classic AI systems of the past. Eliza was in 1964, right? 1964. Way, like, this is your parents' time, right? Maybe grandparents. Very simple chatbot. We're going to talk about more about Eliza later, mostly because of the way people reacted to it. Really surprising. About the same, a little bit later, Dendrol was an expert system which would predict the structure of a molecule. So it turns out that's a difficult problem, and they were able to build an expert system that would do really, really well. Deep Blue came along and beat Boris Spassky, chess champion at the time, and at that point, playing chess was sort of something computers could do better than people, right? Again, algorithmic insights rather than knowledge per se. And a little bit later, IBM's Watson was able to play Jeopardy really well. Interesting story here. Watson was a pastiche. It's basically a giant conglomerate of different pieces of expertise. And it did Jeopardy, the game, really well. Almost nothing else. And IBM tried to sell Watson as a general purpose solution for lots of different industries, medical research, mathematics research, all this stuff. And it almost universally failed because they didn't get the human part right. And I was actually at IBM at the time, and it was like, you guys pay attention. And so it became really well known for doing one thing really, really well, but not a lot of things very well. And of course, AI systems today, right? You know what they do. They do a lot of different things. So we have Roomba, little robots for the house, and we've got Mid-Journey style animation and graphic design packages. Go players is world class. Self-driving cars in ChatGPT and so on. In the interest of time, we're not going to do this. If we had more time, we would do this. But let's see, because I want to do these Venn diagrams really quickly. Because when we talk about AI, there's a lot of different sort of fields you can think about, and you might have thought, well, I was going to learn about this, but I'm going to show you like 4 different Venn diagrams. So this is the Venn diagrams by year, by sort of topical area. So in the middle was an area called cybernetics, and Norbert Wiener was probably the best known person doing this. This is basically control theory. Anybody know what control theory is? Any engineers? Okay. Oh, wow. Control theory. It's basically how do you control complex, usually physical systems by having feedback of various kinds. And it was thought in the 40s and 50s that cybernetics would be the key for intelligence, right? But it turns out that's not as important. There are a lot of other related areas at the time, including control theory, mathematical communication theory, with Shannon and all that stuff. There's a lot of different work all coming together, which then led to, a little bit later, sort of thinking about data science. Data science is the new hotness, right? Everybody wants a school of data science in their university. So Berkeley, you see Berkeley, for example, is building an enormous building, like 3 times the size of this building, just for data science. Stanford just finished their data science building. And I think it's going to be really interesting to see where data science goes with AI. So data science is sort of fundamental. And at Google, I did a lot of data analytics for how people searched or what they were doing and so on. And so data science is the intersection of all of these sort of skill sets where you've got the ability to write code, hack mathematics and mathematics and statistics knowledge, and expertise in a domain. This last area on the bottom is often forgotten because people think, oh, data science will dominate everything else. But it turns out you actually have to know something about the field in order to do effective data science. You can't just go in knowing only data science and hope to succeed. Another perspective on this by Joel Gruss is, there's data science, but then there's hacking and all that stuff, right? But then I like this diagram because you get the James Bond villain at the intersection of evil and substantive expertise with data science, right? So sort of a humorous take on all this whole thing. Now, with respect to HCI and user experience, So classically, user experience is all this stuff about how people experience systems. So that covers things like the design of AI, the design of systems, including testing, iteration practices, information architecture, as well as the user interface design. So it covers everything from typography all the way through information architecture, right? So there are these two fields with a lot of overlap. HCI and AI, what we're doing is all this plus AI, right? So welcome to a complicated class. Human-centered design then is thinking about user experience through these different lenses of people, technology, business, and design. So this is one of the things we're trying to do, is to see how all these different factors interlock together. So when we're talking about a particular AI design, we will easily switch between, for example, methods for doing design, expressions, actually tools for doing that, as well as the vision and the goals of it. None of this is divorced from or separate from actual implementation and building in the world. Then, of course, we've got another set of diagrams here, right? But you see all this stuff is interlocked and related. Okay, let me spend a couple of minutes. I hope to get this done in 15 minutes, but great. A little quick background about a generalized theory of AI. So you probably know a lot of this, but let me use this as a frame for the rest of the class. We think about an agent, there's that word again. An agent is something that takes action in the world. It has percepts, it takes an action, it's got some mechanism, and it has, in the black box here, it's got some thinking component. The question is, what goes on in there? Okay. That's what we think of as AI. So to first order, what the AI thing is we get inputs, we take outputs, we have prior knowledge, we have all this data model, and we create a model, right? So in that model, then, we're trained on data that we can acquire, prior knowledge, and now we try to make that do an output. So from our perspective, it's just making an inference. So you've probably seen a lot of these kinds of things before, right? So here's a data set, and we can model this data set using different mechanisms, right? So you build your standard linear regression, and you get a point on it, that's fine. You could do different approaches to building models, like nearest neighbor, or interpolation, or cyclic, or polynomial, and you choose the model based on what it is you want to do. So for some applications, linear regression is a great model, but it doesn't explain things particularly well, and the polynomial model is quite good, except for that one bump. So which model do you choose and why? That's sort of the fundamental ML engineering question. So what we often do in these systems is we go through a training process, right? So here we go, we've got a linear regression guess, that's not a bad model. And so you're trying this to try to minimize errors on some inputs, right? You can improve your guess, or if you get a more complex space, so this is an easy three-dimensional space. Imagine a 10,000 dimensional space, right? We still go through the same process of minimization or optimization of some form, using the same kinds of algorithms, except you have to modify them a little bit. The classic one is gradient descent, you know this. And there's the story of Gordon the Guided Missile, which is a story by John Cleese, the British comedian, who talks about Gordon, which is a missile, takes off, and every moment on the flight path, he has an error. And he's always trying to reduce the error. I'm not on the flight path, I need to go. And despite being always wrong, he hits his target anyway. And so that's, in some sense, the whole optimization search process, is trying to find a path that minimizes the error and gets you to your output. And so we've got this training set one, we do the training, we've got these different approaches. And the question here is, the standard sort of ML question, are you overfitting to the data? And so what do you do? So that's clearly overfitting, but is this So what are the approaches you need to do? The job of an ML engineer is to find the right model. Build that. And so how many people have seen the iris problem, the iris data set? Oh, everybody's seen it. Okay, great. So you know this. The point I want to make here is that you have this data set. This is not an assignment, it's just a data set. And you can do various kind of visualization techniques and start to see the interior of the data. And you can start to build your ML model. So you could build different kinds of classifiers. A common one is this decision tree model. So basically, you crunch the numbers and you emit this decision path, and you give it the data, and you can classify it pretty accurately, right? And of course, there are neural nets to do all this as well, right? Same idea. Go take that class. You go and learn how to do that. I'm bringing it up just to say that there are these different kinds of models that we can use. You're going to see this picture in almost every single class. This is your reminder to say, what does this have to do with people? How does the ML models affect human behavior or understanding? So I want you to keep this picture in mind as we go through the entire course and ask this question every single time. What does this have to do with humans? How does this affect the way they understand? Is it important that the person know that you have, say, a Bayesian classifier versus a random forest versus whatever? To what extent does that matter? It matters to the engineer, obviously. But how about the end user? So the world is changing, and this is an XKCD example that I really like, because in 2014, which all of you should remember, it's one of these things where you could pose a simple problem. The user takes a photo, the app should check whether or not they're in a national park, right? And of course, that would take a research team plus 5 years, 2014. How long would it take you now? We live in a different world, right? So in this YouTube video, which the link is in the bottom, this guy develops the app to do exactly that in 60 seconds. The world is different now. Because he's obviously going to use a bunch of libraries and external stuff, but nevertheless, this is all possible to do by building on top of the AI repertoire, the AI libraries, the AI services that are out there. So where are we going to be in another 10 years? Or I guess this is what, 7 years? So here's our first little piece of work. This is a sort of fun assignment for today. So you can I actually recommend you do this on a laptop. You can do it on your phone, but it's hard. So get this, and it's Teachable Machine with Google.com. We're going to do a little exercise, okay? It's much easier on your laptop, trust me. What we're going to do is get in groups of 2 or 3, depending on who's got the biggest laptop, okay? And we're going to train a model to do visual discrimination, okay? And what you're going to do is get into teams of 2 or 3 and try to figure out how to build a training sample that will discriminate between different instances of an object. So this is what it should look like for you, right? It's going to look like that. And what you want to do is get started and then choose, I recommend choosing image project. So the one on the left, and create a new project. So you just open that up, use the standard image project. And then you're going to use your webcam to actually allow it on visiting site. And now it'll work better for you because I got this funny video system right now. But then choose 2 different things that you want to discriminate, like a bottle of water versus a cell phone. Can you build a visual classifier to do that? And choose whatever it is you'd like to try to teach it. Go. Find a buddy.
I think it's cost one and cost two.
I would have been so into that.
It's like.
And just like.
Yeah, we can make the 6 months go past, and then
Oh, I
we
see.
see, yeah, and then once it's
That's nice. Yeah, sure.
People ourselves as well.
Very good. Very good.
90% of the time it was right, but the 10% of the time.
Right. And I assume everybody noticed that if, for example, you trained it on 2 phones and you put a water bottle up there, neither would fire. Okay, so that's an example of fragility. So lots of classifiers classify from a distinguished set that may be big. I think next week we're going to use an example of another set of recognizers that recognize for a closed set. It's a big closed set, so it feels open, but it can only recognize what it's been trained on. That's another example of where you see the edges of training. Okay, very good. Oh, great, we're at the end. I didn't realize that. So I hope this is the checkout question for today. Go ahead and do that. And is it broken? Do it right now. Yeah. There's no time like the present. Yeah. Take you just a moment to do that. And I hope you picked up a couple of things today about what this whole class is going to be about, the range of things we're going to cover, the relationship between HAI, HCIAI, and all the other areas of discourse, data science, control theory, all these different kinds of things, as well as a nice grounded example of the way you would train a classifier and the ways in which that fails and what that means for people going forward. All right? Any other questions before we break for today? Yes.
The QR code for the docs.
Oh, the whole thing? Yeah, sure. Let me go back. So first, did everybody get this? Okay. So the question, you wanted to see this, right?
Yeah.
Okay, yeah. And this is the course syllabus, which is a source of all knowledge. Question?